Right. Now, first lesson is basically a reminder of year 11. All right? So the first thing that we are going to look at is actually recall and understand that the gradient function is the derivative of a function, and you can use both the Leibniz and function notation to express the derivative. That's quite important. Know your dy dx or f dash x. All right? Recall how the difference quotient and average rate of change and the generalization of first principle. Should be able to use the power rule to differentiate functions with simple polynomial expressions, negative indices, radicals, and simple products. Be able to calculate instantaneous rate of change, determine the corresponding equations of tangent line to graph, be able to determine the coordinates of points on graphs with specified gradients, and finally solve some practical problems in context using the power rule. All right? Something that you have learned last year, but it's going to bring everything together. Now, start off with given a function, fx. Don't really have to write down everything because I will upload this. All you need to do is listen. All right? The derivative is actually the gradient function. The gradient function defines the gradient at each point of y equals fx, defined in the natural domain and range of the function. So think about it, it could be a quadratic, it could be a cubic. So when you have the derivative of the quadratic or the cubic, what it is telling you is the instantaneous rate of change at each point. All right, it's a gradient at each point. So if you got y equals to x squared, dy dx is 2x. And then at, let's say x equals to 1, what is the gradient? All right, it's tangent to that line. All right, so there are two notation that you need to know: the Leibniz notation, which is dy over dx, or the function notation f dash x. These are the two things that you need to know. Now, difference quotient. Just quickly, just a reminder. You know the average of rate of change from A to B. All right, the average is just the gradient, right? So we can just work out FB minus FA, or actually, if this is Y2, this is Y1, Y2 minus Y1, B minus A, right? Pretty straightforward, you should remember that. Now the next thing you need to know is the limiting Chord process. So what you're thinking about is a numerical approximation. The process of determining the gradient of B, x plus h. So if this is x plus h. And the function of x plus h there by limiting A. Approaching from here, or you could be here, approaching from this side. So all you need to remember is that limit of h approach 0, what is f plus h minus fx over h, that is your derivative. All right? Now, differentiation by the first principle. So the limiting Chord process can be used algebraically to determine the equation of a gradient function. And the instantaneous rate of change, f dash x, is evaluated at a particular value in the domain. So you can really see that this domain, it's all in the real numbers. Sometimes you have a domain which are you've limited the domain. All right. So you got to think about the function. It could be the function could be limited in one domain, certain domains, or it could be the whole real number. All right. So you can use the instantaneous rate of change. You can evaluate it when x equals to a. So that is the point there. The gradient at that point, tangent at that point. Now, this one, good idea to write it down. What is f dash x? Using the first principle, f dash x, just to remind yourself, is limit when h approaches 0, fx plus h minus fx over h. Just a reminder. So we're going to use this again. I'm going to remind you how to do that. Can I move on? All right. So we write that at that point as f dash a. Alright? Now, can you use that? Which is y dx or f dash x equals to limit h approach 0 f x plus h minus fx over h. Can you use that to actually differentiate the following function? Try it first before I show you my answer. If you can remember. If you can't remember, I'll reveal the first bit. So if you look at this, what we're going to do is, let's leave the fx as this, but we are going to substitute x with x plus h. Now, reminder, in the exam last year, heaps of people did not include the x plus h, or something went wrong with how you do it. All right, about a third of you did not do it quite right. So if I write this, the way that I would write it is f x equals to limit h approach 0. Now, I'm going to start off with 2 x plus h squared. All right? Take away 3 x plus h. From memory, a lot of people just wrote down something like this as 3x plus h. You forgot the bracket. So when you substitute in x with x plus h, always remember to put the bracket in. Plus 2. Now, when you take away fx, my suggestion, always put a bracket so that take away, you know that this will be negative, this will be positive, that will be negative. Always remember the bracket is so important. 2x squared minus 3x plus 2. Alright? Over h. So the step-by-step approach I would suggest you to do is always put a bracket in with the x plus h, and then the fx itself put in the bracket. Just to be safe. Just so that you know when you have your negative and you have your positive. Alright, I will leave you to try it out. I'm going to write my solution out. I've guided you with the first step.
Yeah. I'll just expand this part.
All right. Now, hopefully you've done the next two steps, which is expanding it. Doing the first principle is a lot of steps to go through. I know you prefer to use the power rule, but sometimes you do need to know how to use the first principle. So I'll give you a couple of seconds. Remember your brackets.
So much more trickier.
Looking at your answer, I just found out my mistake, which is good. I do that sort of things all the time. I look at students' answer, then I know where I made a mistake. All right, I'll show you where my mistake is. I
In double.
multiply the 2 in to x squared, but I've forgotten those two. It's my fault. It's all right. 2h squared, 2h squared, 4hx, 4x plus 2h minus 3, 3, and I forgot the h. The h shouldn't be there. All right. It happens. So you've got it as 2x minus 3. When I upload it, I'll change my mistakes. All right. So you can see that with the bracket, even with the bracket, these are the mistakes that I'll make. So in the exam itself, you've got to be really careful. All right.
So is the answer 2x equal?
Of course, you would use the power rule. Probably it's a lot easier unless you're asked to use a principle. First principle, I will not bother with that. I'll just use the power rule, which is if fx equals to ax to the power of n, the first derivative is a and x to the power of n minus 1. So you really need to know if there are variables on the denominator is negative indices. Radicals, go for fractional indices. And product of functions. At the moment, expand. Tomorrow we're going to look at chain rule and the product rule on Friday. So don't do that yet, just look at expansion for now. Let's try these three. First one, find f dash x. Pretty straightforward, I'll say. B, find dy dx. And C, find dp dq, please. So what I would like all of you to do is to rewrite or expand it. Now, for C, you don't actually have to give me the answer in radical form. I don't really mind. As long as you know, as long as you can give me in positive indices. So you must remember, if that is q to the power, cube root of q, that is q to the power of 1 on 3. All right? Remember, nth root of something is that to the power of 1 over n. That is one thing that few people might miss.
Thank you.
one who hasn't got it yet? All right. Now, let me review my answer. First two, pretty straightforward, expanding. Now the third one, remember, this is q, 1/3 of q minus 3. So it's therefore 2q cubed minus q to the power minus 8/3. Right? Yeah? Got it? Because that will be 1/3 minus 9/3. So therefore it's minus 8/3. And therefore you've got 6q squared plus 8/3q. Now minus 8/3 minus 1 is minus, that's not 8, that's 3. 11/3. And therefore that is, you can leave your answer as that. You don't actually have to write in radical format. So I did that just to show you. Unless you're asked to write it in radical format, don't worry about writing it in radical format. Or you can give it to me as a positive in the system. Again, look at the questions. Alright? Now, let's continue with this. How do we do D and E? You've got it in front of you. Try that. D, you need to look at ds dt, and E, you need to look at f dash t. Think about how you would change the radical. Try not to skip it. That sort of things. All right. All right, let me show you my answer. I think most of you've got it. Now, can you actually use your class pad to do this?
Yeah, you can just use the differentiate function.
Yeah. Now, be smart. If you are asked to do a difference, if you're asked to differentiate something in the calculated assumed section, you can always use your class pad. All right? Because there could be some pretty complicated thing for you to do.
Sir, I think E is wrong because you put the root t on the bottom.
Root. Sorry. Yep, that's root t should be up. Oh yeah.
Sorry.
I made a mistake.
Let's just change the one.
That's all right. Let's go to the next one. I will sort that out. All right. Let's go to the next one. So example 3, determine the equation of a tangent line to function at this point. Now do it step by step. Of course, you're going to find the derivative of fx first. If you cannot remember, this is what I like to use when I look for an equation of a straight line. Right. Instead of substituting into y equals mx plus c, I actually prefer to use this. It will give you the answer straight away. Y minus y1 equals mx minus x1. All right. Think about how you would use this. You can see that a lot of things you learned from last year and the last 2 years, you've got to bring it back. All right? Very good. Let me review my answer. This is how I did that. 2x minus x1, so it becomes x plus 1. Straight away, I wrote it out, y minus 1. First, of course, I find the derivative, and then the instantaneous rate of change at minus 1, and then y minus 1, which is the coordinate of y is 1, and 2x minus minus 1, which is x plus 1. Therefore, it is y equals to 2x plus 3. All right. Really careful with your negative and positive. Well, look, in the exam, those are the things that I make mistakes. So I really want all of you to think about not to make that sort of mistakes. Negative and positive.
Oh, you've got it. So you just
All right, let's move on to the last example that I have for you. Now this time for the curve defined by the rule y equals to k square root of 4 minus x. You need to determine the value of k such that the line 6x plus y minus 24 equals to 0 is a tangent to the curve at the point 4, 0. Now, in this case, what I would do is multiply everything in. Correct? Actually, before that, let me remind you of something. When you do this, what I like to do is take the fraction out because there's no variable. And then I differentiate that so you can see that the constant is multiplied back in. Makes life a little bit easier for yourself without actually working with fraction. Alright? These are little tips that I will give you. Always try to make sure that when you work on stuff, take the wanted out. Yeah? Does it make sense? If not, you'll be working at t squared over 3 minus 2t over 3 plus 2. Yeah? Okay? Now, so here, think about what you could do with k. Alright? Do we need to multiply k in? No. So what are you going to do? So therefore, you know that y is k times 4x to the power half minus x to the power 3 over 2. Am I right?
Yeah.
Yeah? So if I do not multiply k in, it makes life just that bit easier. Alright, just that bit. Alright, now you got to think about here. What is the gradient? Alright, so you know 6x plus y minus 24 equals to 0. Y therefore equals to minus 6x plus 24. You got the gradient? So you know the gradient y. I skip a step, I haven't done the dy dx yet. So now dy dx equals to k. Half times 4 is 2x. Half minus half minus 3 over 2 x to the power of half. Right? So therefore, we know that at x equals to 4, the gradient is minus 6. Substitute back. Minus 6 equals to k. 2, 4 to the power of minus half, minus 3 over 2, x to the power of half, which is 4 to the power of half. Which means minus 6 equals to k. That would be 2 divided by 2, correct? Because square root of 4, 4 to the power of minus half is 1 over square root of 4. So 2 divided by 2 is 1, minus, this one is 2, 4 square root of 4 is 2, you cancel that off, that is minus 3. So therefore, minus 6 equals to minus 2k, and k equals to 3. Yeah. So always remember, if you've got a constant here, you don't multiply it in. Make life a little bit simple for yourself. Alright? So hopefully with this lesson, I've reminded you what you've learned last year. It's like 2 or 3 weeks lessons squashed into one. Exercise for you to do, you've got about 10 minutes if you want to. Do some of the exercises in Sadler and also the additional exercises.